it was supposed to be unstoppable. The Tiger II, officially designated Panzerkampfwagen Tiger Ausf, B, rolled off German assembly lines in 1944 as the ultimate answer to Allied armour superiority. Thick, sloped frontal armour, an 88mm gun that could punch through anything at ridiculous ranges, and a design that made veteran tankers go pale. On paper, it was invincible. In reality, it was one of the most self-defeating weapons ever built. American tank crews first heard rumours about this new super-heavy tank in the summer of 1944, right after the Normandy breakout. Intelligence reports described it as bigger, heavier, and deadlier than anything the Wehrmacht had fielded before. But nobody had actually seen one up close. Not until September, when a reconnaissance patrol from the 3rd Armoured Division stumbled across something massive, abandoned on a dirt road outside the French village of Gleize. The thing sat there like a beached whale, track links scattered around it, engine compartment, open and gutted. From a distance, it looked like a small building. As the patrol approached cautiously, weapons raised, they realized what they'd found. The first intact Tiger II captured by American forces. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Sergeant Mike Kovacs, a Sherman tank commander who'd been fighting since North Africa, later recalled walking around it for the first time. I stood next to the front Gleize plate and couldn't even reach the top with my arm stretched. This wasn't a tank. This was a moving fortress. And then I noticed something else. The ground underneath was completely chewed up, like the earth itself couldn't handle the weight. Nobody laughed at his observation. Within days, that throwaway comment would reveal one of the most critical flaws in German engineering, a flaw so profound it basically crippled the Tiger II before it ever fired a shot in anger. The Wehrmacht had built a monster that couldn't cross its own bridges. The abandoned Tiger II was quickly hauled to a temporary maintenance depot near Aachen for examination. Word spread fast through Allied command. Engineers, intelligence officers, and tank crews all wanted a look. The British had captured one earlier near Villers-Bocage, but it had been destroyed by its crew before it could be properly studied. This one was different. Mostly intact, fully accessible, a treasure trove of information. The examination team arrived on a cold morning in late September. Major William Richardson, an Army ordnance officer who'd spent years studying tank design, led the American contingent. With him came a dozen engineers, metallurgists, and combat-experienced tankers. They brought scales, measuring equipment, cutting torches, and notebooks. Their mission was simple: figure out everything about this machine and find its weaknesses. The first thing they did was measure it. Length, width, height, every dimension carefully recorded. The Tiger II stretched nearly 34 feet from gun muzzle to rear, with a hull width of over 12 feet. The turret alone was massive, a sloped fortress of steel that rotated on a massive bearing ring. But it was the weight that shocked everyone. Using portable scales and careful calculations, the team determined that this beast weighed approximately 68 metric tons when fully loaded with ammunition and fuel. For context, the American M4 Sherman weighed about 30 tons, the Soviet T-34 around 32 tons. Even the earlier Tiger I had topped out at 54 tons. This new German heavy tank weighed more than 2 Shermans combined. Richardson stood back and looked at his notes, then looked at the tank, then back at his notes. He called over his chief engineer, Captain David Walsh. "Dave, run those numbers again. I need to be absolutely certain." Walsh recalculated, checked the measurements twice, and nodded grimly. 68 tons, sir. Give or take a few £100. This thing is impossibly heavy. And how much can a standard military bridge support? Walsh didn't even need to check his field manual. He'd memorized those specifications years ago. Standard pontoon bridge? About 40 tons safely. maybe 50 if you push it. Engineering bridges built for heavy equipment? 60 tons maximum, and that's with reinforcement. The implications hit them both simultaneously. This tank couldn't use most bridges in Europe. Not the temporary military bridges that engineers threw up across rivers. Not the civilian bridges in French and Belgian villages, many of which were centuries old and built for horse carts, not armoured vehicles. Not even many of the modern concrete bridges designed for civilian truck traffic. Richardson walked around the Tiger II again, this time with different eyes. He wasn't looking at a weapon anymore. He was looking at a logistical nightmare. How the hell were they moving these things? He muttered. The answer came from interrogating captured German tankers and engineers over the following weeks. The stories they told painted a picture of absolute chaos. One panzer commander from the 501st Heavy Panzer Battalion described a mission where his unit of 6 Tiger IIs was ordered to advance 30 kilometers to reinforce a defensive position. It took them 3 days to cover that distance, not because of combat, but because they had to find routes that could support their weight. We sent reconnaissance ahead to mark which roads were paved strongly enough, which bridges were reinforced, where we could ford rivers if necessary, the commander explained through a translator. Every small stream became a major obstacle. Every village bridge a potential disaster. We moved slower than infantry on foot. Another captured German engineer, Hauptmann Klaus Zimmermann, was even more blunt. The Tiger II was designed by people who never had to move one. We'd get orders to deploy them to the front, and immediately we'd have to start calculating load capacities, requesting engineers to reinforce bridges, or finding detours that added hours to the journey. Half the time, the detours took us through terrain the tank couldn't handle, soft ground that those tracks would sink into like quicksand. The Americans began testing this theory. They found a small stone bridge near the depot, one rated for about 30 tons of civilian traffic. Using a captured German tank transporter, they carefully positioned the Tiger II on the approach and began inching it forward. Engineers placed strain gauges on the bridge supports and watched nervously. The tank was halfway across when they heard it. A deep, grinding crack, not a sudden snap, but a slow, inevitable fracturing of stone that had stood for over 100 years. They immediately reversed the Tiger II off the bridge. The damage was done. Massive cracks spider-webbed through the main support arch. The bridge was no longer usable. They tried, again with a reinforced military pontoon bridge, the kind engineers could assemble in a few hours to cross rivers. This one was rated for 50 tons, theoretically. The Tiger II rolled onto it slowly, spreading its weight across the width of the bridge. The pontoons immediately sank lower in the water. As the tank reached the center point, the entire structure began to buckle. Water poured over the edges of the pontoons. The engineers frantically waved the driver back before the whole assembly collapsed. A British liaison officer watching the test, Major Thomas Blackwood, summed it up perfectly. "Jerry's built himself a brilliant tank that can't actually get to the war. Bit of a design oversight, wouldn't you say?" But it wasn't just bridges. The examination team discovered the weight caused cascading problems. The transmission and final drives, already notorious for being fragile on the Tiger I, were under even more stress. The Tiger II used essentially the same drivetrain as its predecessor, but had to push significantly more mass. Breakdowns were constant. Captured maintenance logs showed that Tiger II battalions spent more time repairing their tanks than fighting with them. The tracks themselves were another engineering compromise. To distribute that enormous weight, the Tiger II needed absurdly wide tracks, over 30 inches. But tracks that wide couldn't fit on railway cars, the primary method of moving heavy tanks long distances in Europe. So German engineers designed 2 sets of tracks, combat tracks for operational use and narrower transport tracks for railway movement. This meant every time a Tiger II needed to move by rail, the crew had to remove the combat tracks, install transport tracks, load the tank onto a rail car, transport it, unload it, remove the transport tracks, and reinstall the combat tracks. The process took hours, and required special equipment. In combat conditions, it was nearly impossible. Major Richardson compiled all these findings into a report that he transmitted back to Allied Command. The title was succinct: Tiger II, Analysis Tactical Capabilities versus Strategic Limitations. His conclusion was even more direct. The enemy has produced a tank that is tactically formidable but strategically crippled. Its weight makes it nearly immobile in practical terms. Recommendation: do not attempt to replicate this design philosophy. The Americans weren't alone in their assessment. Soviet forces captured several Tiger IIs on the Eastern Front and came to identical conclusions. A Red Army testing report from late 1944 noted, "The fascist heavy tank possesses thick armor and powerful armament, but cannot maneuver effectively due to excessive weight. Bridges collapse, roads are destroyed, fuel consumption is catastrophic, not suitable for offensive operations." That last point about fuel consumption was another discovery. The Tiger II's Maybach HL 230 engine, the same one used in the Panther tank, was now pushing significantly more weight. Fuel economy was disastrous. The tank could manage maybe 70 to 80 kilometers on a full tank of fuel under ideal conditions. In combat, constantly maneuvering and working the engine hard, that range dropped to 50 kilometers or less. For comparison, a Sherman could travel over 200 kilometers on internal fuel. Even the gas-guzzling Panther managed around 170 kilometers. The Tiger II was essentially tethered to its fuel trucks, unable to operate independently for any length of time. German logistics personnel captured during the Battle of the Bulge told Allied interrogators about the fuel nightmare. One supply officer described trying to keep a company of Tiger IIs operational during the Ardennes offensive. "We requisitioned more fuel for 6 tanks than we did for an entire panzer division of medium tanks, and they still ran out. We found 3 of them abandoned on the road, not destroyed by enemy action, simply out of fuel with no way to move them." The examination team at Aachen moved from studying the tank's weight problems to analyzing its armor. Here, at least, German engineering had succeeded. The frontal Gleize plate was 150 millimeters thick, sloped at 50 degrees. Using trigonometry, that meant effective thickness against a perpendicular shot was nearly 230 millimeters of steel. No Allied tank gun could penetrate that. Not the Sherman's 75 millimeters, not even the new 76 millimeters high-velocity gun. British 17-pounders might have a chance at close range, but only from the sides or rear. Captain Walsh ran penetration tests using captured German ammunition. They set up armor plates at various angles and fired at them from different ranges. The results were sobering. "From the front, this thing is immune to almost everything we have," Walsh reported. "Our standard armor-piercing rounds literally bounce off. I watched a 75mm shell hit the Gleize plate and ricochet straight up into the air like a skipping stone." But then they tested the side armor. At 80mm thick, it was still substantial, but no longer impervious. A well-placed 76mm shot could penetrate at ranges under 1,000 yards. The rear armor was even thinner, around 80mm with minimal sloping. The turret sides were vulnerable too, especially the area around the turret ring where armor had to be thinner to allow rotation. The examination team realized something crucial. The Tiger II's designers had created a tank that was nearly invincible from the front, but vulnerable from every other angle. And because of its weight and mobility issues, it couldn't easily maneuver to keep its front armor facing threats. In fluid combat, where tanks had to move, turn, and react to threats from multiple directions, that 68-ton weight became an anchor. Richardson documented everything. The team took thousands of photographs, created detailed technical drawings, measured every component, and tested every system. They examined the gun, a formidable 88mm KOK, 43 litres, 71 that could destroy any Allied tank at ranges exceeding 2 miles. They studied the optics, some of the best in the world. They analyzed the ammunition storage, the crew layout, the fire suppression systems, but every positive discovery was overshadowed by that fundamental flaw, the weight. It permeated every aspect of the tank's design and operation. The suspension system, using torsion bars and interleaved road wheels, was incredibly complex. Beautiful engineering, except those interleaved wheels trapped mud and debris, which froze solid in winter. Crews spent hours with blowtorches thawing their own tracks every morning in cold weather, and if one of the inner road wheels was damaged, you had to remove multiple outer wheels to access it. A simple repair job that took an hour on a Sherman took an entire day on a Tiger II, assuming you had the spare parts, which captured Germans admitted they rarely did. By October 1944, the examination team had compiled enough data to brief General Omar Bradley and other senior commanders. Richardson stood in front of a room full of generals and colonels, presenting his findings. He started with the impressive specifications: the armor thickness, the gun performance, the advanced optics. The room was silent, tension building. Then he flipped to a photograph. A Tiger II, abandoned on a road, tracks spread out beside it like the legs of a dead spider. This, gentlemen, is how we've found most of them, not destroyed by our forces. Abandoned by their crews due to mechanical failure, lack of fuel, or simply because they couldn't navigate the terrain. Telling and preparing this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. He showed another image. The stone bridge they'd damaged during testing, cracks visible even in the grainy photograph. This is what happens when the Tiger II tries to cross a standard European bridge, and this is a reinforced structure. Field bridges fare even worse. Bradley leaned forward. So you're telling me their supertank is basically useless? Not useless, sir, Richardson corrected. In a static defensive position, on solid ground, with fuel and ammunition supplied, it's devastating. But in mobile warfare, in offensive operations, it's a liability. The enemy has built a bunker on tracks, except the tracks barely work. The briefing changed Allied tactical planning. Instead of developing new weapons specifically to counter the Tiger II, commanders focused on exploiting its weaknesses. Avoid frontal engagements, maneuver around them. Force them to move, because movement killed these tanks more effectively than any shell. American tank commanders began sharing tactics. If you encountered a Tiger II, don't try to slug it out head-on. Call in artillery to force it to relocate. Request air support, because the Tiger II couldn't run from P-47 Thunderbolts carrying rockets. Use terrain to your advantage, force them onto soft ground or toward bridges they couldn't cross. One memorable after-action report from the Battle of the Bulge described a Sherman platoon that encountered two Tiger IIs blocking a road near Bastogne. Instead of engaging, the Sherman commander simply directed his platoon to bypass them through adjacent farm fields. The Tiger IIs, weighing twice as much, couldn't follow through the soft ground. They got stuck and were later destroyed by infantry with bazookas when they tried to reverse out. The Soviets took an even more aggressive approach. Red Army tactics emphasized combined arms warfare, using infantry, artillery, and tanks in coordination. When Tiger IIs appeared, Soviet commanders would pin them down with artillery fire, while T-34 seconds maneuvered around their flanks. The T-34 seconds, at half the weight, could go places the Tiger II couldn't dream of reaching. Back at the examination facility, Richardson's team continued their work. They wanted to understand why German engineers had made these choices. Surely, they knew about the weight problems. The answer came from captured design documents and interrogations of German tank designers who'd been apprehended by advancing Allied forces. One engineer, whose name was redacted in the reports, explained the pressure they'd worked under. We were told to make it impenetrable. Every time we presented a design, Hitler himself would demand thicker armor. We'd explain the weight penalties, the mobility issues, but it didn't matter. Thicker armor was the priority. So we kept adding steel. Another designer described the gradual mission creep. The Tiger II had started as a design for a 50-ton heavy tank. Then requirements changed. More armor, bigger gun. More ammunition storage, better optics, thicker side armor. Each addition added tons. By the time the design was finalized, it was 68 tons, but production schedules were set, factories were tooled, and there was no time to redesign the drivetrain and suspension to handle the additional weight properly. The result was a tank that embodied the worst aspects of late-war German engineering: over-engineered, under-tested, and impractical for actual combat conditions. It was designed in a vacuum by engineers who prioritized theoretical performance over practical utility. Richardson's final report to Allied headquarters was over 200 pages long. It included detailed technical specifications, armor penetration charts, photographs, captured German documents, and tactical recommendations. But the executive summary was just 3 sentences. The Tiger II is a failure of systems engineering. Its individual components are excellent, but the complete vehicle is operationally ineffective due to excessive weight. Recommend no changes to Allied tank development in response to this threat. That recommendation was followed. The United States continued developing the M26 Pershing, a heavy tank that weighed 46 tons, thick enough armor to resist most German guns, powerful enough to threaten German armor, but light enough to cross bridges and maintain strategic mobility. The British continued with their Comet and Centurion designs, both emphasizing balanced performance over extreme specialization. The Tiger II became a case study in what not to do. Military academies after the war used it as an example of poor systems integration. Yes, you can build a tank with impenetrable armor and a devastating gun, but if it can't reach the battle or maneuver once it gets there, you've wasted resources that could have built 3 or 4 more practical tanks. The Germans produced about 489 Tiger IIs between January 1944 and March 1945. For comparison, in that same time period, the United States produced over 25,000 Sherman tanks, and the Soviet Union produced approximately 15,000 tons 34 seconds. Even if the Tiger II had been tactically perfect, it was strategically irrelevant because of the numbers game. But it wasn't tactically perfect. American tankers who encountered Tiger IIs in combat reported that they were dangerous when encountered in prepared defensive positions, but only if you were foolish enough to charge them head-on. One veteran Sherman commander, Captain Jim McLeod, described an engagement near the Remagen Bridge in March 1945. "We came around a bend and there's this massive German tank turret pointing down the road. I immediately reversed behind a building. My gunner was panicking, saying we had to engage. I told him to calm down and think. That Tiger was guarding a bridge, which meant it couldn't leave, because if it tried to cross that bridge, it would collapse. So we just called in artillery coordinates and waited. 20 minutes later, the Tiger took a direct hit from a 155mm howitzer and brewed up. Never fired a shot. That engagement summarized the Tiger II's war, intimidating when you first saw it, but ultimately defeated by its own limitations. German crews knew this too. Interrogation reports from the last months of the war described Tiger II tankers who were almost relieved when mechanical failures forced them to abandon their vehicles. One captured loader told his interrogators, "That tank was a coffin. Too slow to escape, too heavy to move, always breaking down. When the engine finally died for good, I felt like I'd been given a reprieve." The examination team at Aachen eventually finished their work. The captured Tiger II was shipped to the Aberdeen Proving Ground in Maryland for further testing. It sits there today, in the outdoor collection, slowly rusting, Tourists walk around it, marvel at its size, take photographs standing next to the massive gun barrel. Few know the full story of why it failed. The legacy of the Tiger II isn't its combat record, which was mediocre at best. It's the lessons it taught about engineering. Modern tank designers study it as a cautionary tale. The current American M1 Abrams weighs about 68 tons, the same as the Tiger II, but it has a 1,500 horsepower turbine engine that can push it to 42 miles per hour on roads. It has sophisticated suspension that can handle that weight. It was designed from the beginning as a complete system, not as an armor plate with tracks bolted on as an afterthought. Military bridges today are rated for much higher weights because engineers learned from World War II that heavy armor would only get heavier. Modern militaries maintain both permanent and portable bridging equipment rated for 70 tons and above. Logistics became recognized as equally important as firepower, a lesson the Tiger II taught through its failures. In some ways, the Tiger II was ahead of its time, a main battle tank concept in an era when the supporting infrastructure didn't exist. If it had been designed 30 years later, with modern metallurgy, composite armor, powerful engines, and sophisticated transmissions, it might have worked. But in 1944, with wartime production constraints, limited resources, and desperate requirements, it was a magnificent failure. Major Richardson retired from the Army in 1946. He went on to teach mechanical engineering at MIT, where he used the Tiger II as a case study for decades. His students would analyze the design choices, debate alternatives, and learn that sometimes the most impressive solution isn't the most effective one. One of his favorite exam questions was, "You have been tasked with designing a heavy tank, unlimited budget, best materials, skilled workers. What is your weight limit, and why?" Students who answered with, "as heavy as possible for maximum protection," failed. The correct answer, which Richardson would explain patiently, was as heavy as necessary to achieve mission requirements while maintaining operational mobility. The Tiger II had forgotten the second half of that equation. Today, military historians still debate the Tiger II's effectiveness. Some argue it was a terror weapon, meant to demoralize Allied tankers rather than achieve tactical victories. Others see it as a symbol of Nazi Germany's decline, building wasteful superweapons when they needed practical equipment. A few apologists claim it was brilliant but misused, though those arguments tend to ignore the fundamental physics of moving 68 tons across European terrain. The truth is probably simpler. The Tiger II was an example of engineering excellence divorced from strategic reality. It was what happens when designers optimize for a single metric, in this case, frontal armor protection, without considering the complete operational environment. It was a lesson written in steel and frustration, paid for by German factory workers who could have been building 3 Panthers instead, and ultimately learned by American engineers examining an abandoned monster on a French road. That first captured Tiger II sits in Maryland still, a monument to the principle that sometimes the biggest, heaviest, most powerfully armed option is actually the worst choice. Sergeant Kovacs, the Sherman commander who first walked around it in 1944, visited Aberdeen in 1989, 2 years before he died. He stood next to the tank again, older now, his hand resting on the same Gleize plate he couldn't reach decades earlier. The museum was quiet that afternoon, the kind of quiet that seems to respect its own echoes. A few tourists wandered between exhibits, murmuring softly, their sneakers squeaking faintly against the polished concrete. Sunlight slanted through high windows, catching dust motes that drifted lazily in the still air. Outside, the autumn wind stirred the American flag on its pole. Inside, beneath the tall ceiling of the armored vehicle hall, stood the giant. The Tiger II, the Königstiger, loomed like a myth given form all sharp angles, thick plates, and cold menace. Its paint, faded but intact, still carried the harsh camouflage patterns of the late war. Dark greens and browns bleeding into one another like bruises. Its 88mm gun jutted out into space, aimed at nothing, but dominating everything. Visitors stopped, stared, took photographs, whispered about its size, its presence. It was more than a machine. It was an artifact of ambition and arrogance, power and futility. Retired Colonel James Kovacs stood before it, hands clasped behind his back, his posture still military, even after 40 years of retirement. He was in his 90s now, his spine slightly bowed, but his eyes sharp, grey, unyielding, took in the tank with the quiet recognition of someone who had once seen such things through the haze of smoke and fear, not museum glass. A young army officer, early 30s, crisp uniform, the kind of confidence that came from a peacetime career, had recognized him earlier from the name tag on his visitor pass. Kovacs had once been something of a legend among armor historians, a veteran of the 11th Armored Division, one of the few officers who had faced the Tiger II in combat and lived to tell about it. The young officer, eager to connect past to present, had struck up a conversation and, finally, asked the question that had brought Kovacs back into memory's battlefield. "Sir, what do you think of it all these years later, now that the emotion and danger have faded into history?" Kovacs didn't answer right away. He stared at the machine for a long time. His hand trembled slightly as he rested it on his cane, but his mind was elsewhere in another time, another landscape. The silence stretched until even the hum of the museum lights seemed to fade. Then, softly, he began to speak. He remembered Belgium, winter of 1944. The forests were thick and cold, the roads choked with snow and mud. Their Shermans, thin-skinned, reliable, and perpetually undergunned, moved cautiously through the fog, engines growling like tired dogs. The Battle of the Bulge had turned every hedgerow into an ambush, every tree into a potential hiding place for something bigger, meaner, and German. The first time he saw a Tiger II, it appeared out of the mist like a moving fortress. Its size was absurd, taller than a man, heavier than a house. It rolled forward as if the earth itself should be honoured to hold its weight. The first 75mm rounds from the Shermans bounced off its frontal armour like stones against a battleship. The Tiger's gun fired once, and one of his platoon's tanks vanished in a blossom of fire. "We couldn't hurt it from the front," he remembered aloud. "We knew that. So we had to dance with it, flank it, trick it, pray it turned the wrong way. The trick wasn't to kill it outright, but to outthink it before it could bring that gun to bear." He paused, the images vivid behind his eyes. The sounds came back too, the ringing inside his helmet after a near miss, the metallic clang of shells, the smell of oil, cordite, and blood. "You'd think something that big would be unstoppable," he went on. "But it wasn't. It broke down more often than it fought. We'd find them abandoned. Thrown treads, empty fuel tanks, gearboxes frozen solid. You could hear them coming miles away, engines screaming like they were dying. They were impressive, sure, beautiful engineering, but war doesn't reward beauty." He tapped his cane lightly on the concrete, as if to underline the point. The young officer listened, captivated. Kovacs's gaze lingered on the tank's drive sprocket, a marvel of machining, overcomplicated but precise. "They built these things like they were making jewelry," he said. "Everything machined to the micron. Every gear, every weld perfect. But in war, perfection kills you. You need something that can be kicked back into gear with a hammer, not something that needs a factory." He recalled a day near Bastogne, early January 1945. Snow still falling. His Sherman had thrown a track on an icy incline. The crew jumped out, freezing hands working with crowbars and sledgehammers to get the track back on. It took them 2 hours. A Tiger II, immobilized by something similar, might never move again. It needed a crane and a maintenance crew that no frontline unit could afford. Sometimes, he said with a faint smile, we won just by being able to keep moving. That's all. We got to the fight. They didn't. He looked again at the monster before him. They lost the war with machines that collapsed their own bridges, he said quietly. We won it with tanks that could cross them. The officer frowned slightly, as if trying to reconcile the old man's words with the myth he'd grown up hearing. The Tiger II had always been presented as the pinnacle of German engineering, the terror of Allied armour, a masterpiece of design. And in a way, it was. On paper, it was unbeatable. 150 millimeters of front armour, an 88 millimeters gun capable of killing a Sherman from over a mile away. Optics so advanced they looked like they belonged to another century. But Kovacs knew what the paper never showed: the mud, the rain, the logistics, the human cost of complexity. Every one of these things, he said, took about 300,000 man-hours to build. You could make 5 Shermans in the same time. 10, maybe, if you were in a hurry. And the Shermans didn't need to be shipped in pieces and assembled by engineers. They just worked. We could fix them with whatever we had: a wrench, a prayer, and some duct tape. He chuckled softly, the sound dry and rueful. You don't win wars with the best machines. You win them with the best systems. The Tiger was a weapon. The Sherman was part of a machine called production, logistics, supply, maintenance, and willpower. That's what wins wars. He looked at the young man, who was still absorbing it all. You can have the best tank in the world, he said, but if it's out of fuel, out of parts, and out of time, it's just a bunker on treads. For a while they stood together in silence. The museum's lighting glinted off the Tiger's armour, casting long, sharp-edged shadows. Kovacs's mind drifted further beyond the war, to the years afterward. He'd stayed in the army, served in Korea, then in advisory roles through Vietnam. He'd seen the same lesson repeat itself in different forms. Nations falling in love with the idea of technological supremacy, forgetting that war was still fought by people, in mud, under stress, with imperfect information and limited time. The Germans believed in genius, he said at last. One perfect solution to every problem, one tank to rule them all. But perfection doesn't scale. It's brittle. When it fails completely. He thought of the Allied supply lines, the endless convoys of trucks carrying fuel and parts, the engineers building makeshift bridges overnight. He thought of the soldiers who kept going, not because their machines were invincible, but because they were repairable, replaceable, human. The Tiger II was a monument to pride, he said, and pride is heavy, it sinks in the mud. He turned to the young officer. Do you know what really scared us? He asked. Not their tanks, their artillery, their discipline, their ambushes. The Tiger was just a symbol, a psychological weapon. If you saw one, you remembered it for life. But most of us never did. They built less than 500. That's nothing. We built 49,000 Shermans. He took a slow breath. War isn't about how many you can destroy. It's about how many you can keep fighting with. The officer nodded slowly, understanding dawning. So when people ask me what I think of it, Kovacs said, gesturing to the tank, I tell them the same thing. Impressive machine, beautiful engineering, completely useless. They built a masterpiece that couldn't do the job it was made for. We built tools that did. That's the difference. He patted the armor once, almost affectionately. The steel was cold beneath his wrinkled hand, but familiar. Sometimes the best weapon is the one that actually works, not the one that looks most impressive on paper. He stepped back, his cane tapping lightly on the floor. The young officer thanked him quietly, sensing that the conversation had ended. Kovacs nodded, then began to walk toward the exit, slow but steady. Behind him, the Tiger II sat silent under the Maryland sun that filtered through the skylights, its long shadow stretching across the museum floor. To the tourists, it remained a monument to lost power, a beast that once ruled the battlefield. But to Kovacs, it was something else, a lesson cast in steel. He had seen too many good men die because someone somewhere believed that perfection could win a war. He had watched divisions grind to a halt because the tanks that were supposed to save them had instead become immovable, fuel-hungry idols. The Germans had built gods of war. The Allies had built soldiers' machines. History had decided which mattered more. As he reached the doorway, he turned one last time. For a moment, his eyes softened. He didn't hate the Tiger. He respected it, respected the minds that made it, the hands that built it, even the men who fought inside it. They were not villains to him, just fellow soldiers trapped in the machinery of their own nation's overreach. The Tiger's massive form seemed almost sad now, a relic of misplaced brilliance. In its stillness, it spoke of a truth as old as war itself, that the line between genius and folly is often drawn in mud, not ink. Outside, the air was crisp and cool. Kovacs adjusted his hat against the sunlight and continued down the museum path, his shadow long and thin on the pavement. Visitors passed him, unaware that the frail old man with the cane had once commanded tanks under fire. He thought of his crew, 5 young men bound together by noise, mud, and fear. Their faces came back to him now with startling clarity. Peterson, the gunner, who swore like a sailor but could hit a target half a mile away. Morales, the driver, a farm boy from Nebraska, who treated their Sherman like it was his tractor back home. And little Jack Ellis, the loader, barely 20, who used to sing to steady his nerves between engagements. They had fought not with perfect machines, but with what they had: a tank that rattled when it turned, smoked when it climbed a hill, and leaked oil like a wounded beast. Yet it kept going, because they kept it going. He remembered nights spent under the hood, working by the dim light of a lantern, hands black with grease, while German artillery rumbled somewhere beyond the tree line. They learned to patch fuel lines with chewing gum and tighten track pins with a crowbar. When the transmission jammed, Morales would curse in Spanish until it coughed back to life. When they ran low on rations, Peterson traded chocolate for gasoline with another crew. They weren't soldiers of Taby times, some grand mechanized doctrine. They were craftsmen of survival. Kovacs could still hear their laughter in the stillness between battles. The way Ellis told bad jokes to keep the fear at bay. The way Peterson bragged that their Sherman had more heart than any Kraut tin can. The way they celebrated every small victory, crossing a bridge, surviving an ambush, making it through another day. Those moments, fleeting as they were, kept them human. He had seen men die inside the same type of tank he now saw displayed behind ropes and placards. He had seen fire bloom through open hatches, heard the metal scream as shells tore through armor. There was nothing glorious about it. The tank wasn't a fortress, it was a coffin on treads, and survival depended on luck as much as skill. Yet through it all, his crew endured. They learned to adapt, to improvise, to keep moving when everything around them wanted to stop. Standing before the Tiger II, Kovacs understood the irony. The Germans had built a masterpiece, massive, powerful, intimidating, but in the end, it was crippled by its own perfection. It demanded too much fuel, too much maintenance, too much of everything. His Sherman, by contrast, had been crude but dependable, a tank made not for parades but for war. He smiled faintly at the thought. The Tiger II might have been a king in name, but in the end, it ruled over nothing but ruins. Behind him, the great machine stood silent under the museum lights, a 68-ton monument to the truth that in war, as in engineering, there are no points for style when you can't complete the mission. Up next, we have 2 more incredible stories that are waiting for you. Just click the image you want to watch, and it will take you there. If you enjoyed this video, make sure to subscribe, it would mean a lot.